Garbage collection feels like magic. You create objects and a background process cleans them up. But that magic comes with a steep price tag, unpredictable latency spikes. In languages like Java, Go, or Python, a tracing garbage collector periodically scans your heap. When memory fills up, it triggers a stop, the world pause. In real-time systems, financial trading, or game engines, a 50-millisecond pause is fatal. So, how does Rust manage memory without a garbage collector and without making you write manual free statements like in C? The secret is a fundamental concept called RAII, Resource Acquisition Is Initialization. In Rust, memory ownership is tied directly to the lexical scope of your variables. Under the hood, Rust powers RAII through the drop trait. When a variable goes out of scope, the compiler automatically injects a drop call at compile time. No background thread scanning memory, no runtime overhead. This is what Bjarne Stroustrup called a zero-cost abstraction. What you don't use, you don't pay for. And what you do use, you couldn't handcode any better in C. To recap, tracing garbage collectors pause your application at runtime. Rust uses RAAI and the drop trait to inject deterministic cleanup instructions directly into your binary at compile time. Next up, ownership and borrowing. How the borrow checker enforces safety without locks. Stay tuned and subscribe to the channel so you don't miss future videos.